All right, last video, guys, and it's only dealing with Ohm's law, which deals with voltage. You might see this if you ever take AP Physics. Sometimes they use different letters, VI and R. Sometimes I think you'll see the letter Z in here, but this is probably the most common one that I can find. So basically, they use imaginary numbers, to work with circuits and voltage and things like that, things that you might not think of. Basically, to keep, two parts the same, but they can cross paths and turn into I squareds and all that stuff. The difference is they actually use J instead of I, but it denotes I. It works the same way as I. When you do the problems, you probably just want to even write I and then just as your final answer, throw the J back in there. Or you can leave it as J, right? Whatever you want. But we need to know what these V's and I's and R's stand for. And V is probably the easiest one, right? So V equals I times R. And V, as you may have guessed, stands for voltage. Voltage, okay? And that's something we measure in volts. The I, I don't know if you guessed it, the I stands for the current, right? So it's like the electricity current. So I'm going to put C-U-R-R-E-N-T. And that's something we measure in amps, right? So this is kind of confusing. V, voltage, volts, that makes sense. They all begin with V. I actually stands for the current, and we measure it in amps, right? So you kind of just want to know that as we go through. And then R, which is going to be last, it actually kind of makes a little bit of sense. It's the resistance that's within the current, right? So it kind of goes different direction. So resistance. And that's measured in something called ohms, right? It's called Ohm's law. So R is resistance. That one makes a little bit more sense for us. So, we get certain problems that are related to this and they can be measured with imaginary. These are usually what you're going to see in terms of your problems that deal with imaginary numbers. So you might as well get used to them, right? So the resistance in one part of a series circuit is 2 plus 8I, or J8 ohms. And the resistance in another part is 4 minus J6 ohms, right? So find the total resistance. This one's not so bad on our pain scale. It doesn't even involve voltage or or current. It just involves resistance. So the total, you just add these two things up, right? So you have 2 plus 8. I'm just going to rewrite it with I's because I'm comfortable with them. So it's 2 plus 8I, and then plus 4 minus 6I, or J6, right? You can keep it as J's if you want to. We can put parentheses around it, but with the addition, we should be okay. The final answer would be 6, and then plus, I'm going to write it as J2, and then ohms. Make sure you label all of your final answers here for full credit. And that's it, right? Got rid of the I's and put the J back in there just as part of my final answer. That's it. All right, so a little bit trickier here. This guy doesn't look quite as happy. The current in a circuit is 4 plus J2 amps, and the resistance is 5 minus J ohms. What is the voltage, right? So if you remember from the last slide, voltage is the current multiplied by the resistance. So if we have a current and a resistance to get the voltage, we need to multiply these two things together. And again, I'm just going to use I. So I have 4 plus 2I multiplied by 5 minus, I'm just going to write it as 1I, or just I, instead of J. Ohms, and that's it, right? So this is amps times ohms, and amps times an ohm would equal a volt, right? So it's not like amps ohms as the final. It's actually the unit would just be called a volt. Right, so now we're just going to, again, distribute the 4 to both. We're going to get, well, you can do it out, right? I'm just going to give you the final answer. It's going to be 22 plus 6I. But in our case, we are actually going to use it as 22 plus J6. And that would be volts. And that would, whoops. And that would be our final answer. Okay? And try this last one on your own, and then if you get this one right, good for you. You've graduated today's lesson. All right. So final answer here, if you got it, is going to be 7 minus J6. And it asks for current, so the final answer is going to be amps. And how did we get that in case you didn't get that? Right, well, it's going to be 45 plus J10, right? That's the voltage. So if you need to find the current, you can take the voltage and divide it by the resistance, right? So if you needed to solve for the current, you could divide both sides by R, and you get voltage divided by 1 would equal, the other one, essentially. So in this case, I'm going to have 45. I'm going to get a different color here. I'm going to get 45 plus J10, right? So 45 plus 10I. Here we go. Over 3 plus 4I. And I'm just going to leave it like that for now. So I have a complex number on the denominator. I have a square root on the denominator. So I'm going to multiply it by the conjugate. So 3 minus 4I. And 3 minus 4I. And then that will give me something that will be more complicated on the top, right? So 3 times 45 is going to give me 135. 45 times negative 4 is going to give me negative 180i. And then I'm running out of room, but 3 times 10i would be 30i. So plus 30i, and the negative 4i times 10i would be 40i squared, which I squared is negative 1. I'm just going to put minus 40, right? 40i squared is the same thing as negative 40. And that should take care of that part. The denominator, not quite as bad, right? The conjugates work because the middle things cancel, so it's going to be 3 times 3, which is 9. And then negative 4i times positive 4i is going to be negative 16i squared. But again, with these i's, it always turns into a plus, right? Because it's minus a negative with the I squared. So you're getting it 9 plus 16. And then if we simplify, right, 135 minus 40, like terms, right? That's going to give us, actually, I'm sorry, I screwed this up. You might have caught it. It's minus 40i squared, which is going to turn this 40 into a plus 40. I'm sorry, I did see that, right? So negative 4i times 10i is negative 40i squared. And when you do negative 40i squared, it's going to turn into positive 40. So screwed that up. All right, so 135 and 40 is 175. And then negative 180 plus 30 is negative 150 all over 25. Oh, negative 150i all over 25. Just happens that each of these three terms are all divisible by 25. So if that's the case, divide them all by 25, right? If this was 149, then don't just divide these two. It has to be all three. But in this case, it is, right? So when you divide 175 by 25, you get 7. When you divide 150 by 25, you get the 6. And then 25 divided by 25 is 1, so there's no denominator left. So there you go. That's how you get it, right? So that's it for the lesson, right? I'm going to leave this slide open for you if you want to, but it's really just a recap. You got A and BI. A is the real part. BI is the imaginary part. And then we kind of already talked about how you can represent regular numbers with the same format. So that's it. Good job today, guys. If you finish before the bell gets out, good for you. You can start the homework, which is on Schoology.